5 part 2 gives us some interesting questions, and it starts to get a little bit trickier for some students, but we'll get through it and see where we're at. So we'll start with problem 351. It says recall the 1-in-1 situation from problem 326. So remember, if you make the first shot, you shoot again. If you miss the first shot, then you don't shoot again. So it says use a model to represent the sample space. You can see I already got a head start and I made this, so I'm already done with that. It says what's the most likely of the 3 possible outcomes? Well, the first shot you're 60% likely to make, you're 40% likely to miss. If you miss it, you get 0 points and you're done shooting. If you make it, you shoot a second shot. If you make it, 60% chance, miss it, 40% chance. So 0.6 times 0.6. 0.36 or 36% chance of scoring 2 points, 0.6 times 0.4, 24%, 24% chance of making 1 point, and then of course 40% chance of missing and getting no points. I will point out, I always like to do the first thing on the top and the second thing on the side. Earlier, the book does the first thing on the side and the second thing on top. So, I'm probably doing it wrong. I should probably do that. It makes sense to me to put the first thing on top and the second thing on the side, but technically speaking, it might make more sense to have the y-axis and then the x, but whatever. As long as you know what you're looking at, it shouldn't make that big of a deal. So use a model to represent the sample space. What's the most likely of the 3 possible outcomes? Well, the most likely is 0 points is the most likely, right? That happens 40% of the time. 2 points is only 36, 1 point is 24. It says, is it more likely that Delilah would make no points or that she would score some points? Well, I would say some points, right? The 2 points plus 1 point is more than 0 points, even though 0 points is the most likely to happen. And I should say odds of up here, right? Odds of 2 points. So let's see if we can clean this up. Not looking great. Let's try this. There we go. All right. So the most likely scenario is some points. The odds of 2 points plus 1 point is more than 0 points, even though 0 points is most likely to happen, right? So 36 plus 24 gives us 60%. 60% chance is going to score some points. That's more than the 40% of none. So it says on average, how many points would you expect Duncan Delilah to make in a 1-in-1 free throw situation? That is, what's the expected value? So that's a pretty interesting question here. So we expect to make, and I'm going to use decimals on this one. We're going to say, I want to get rid of that there. We would say she expects to make 2 points 0.36% of the time. Plus, she expects to make 1 point 24% of the time. Plus, she expects to make no points 40% of the time. So 2 times 0.36 is 0.72 points. Plus 1 times 0.24 is 0.24. Plus 0 times 0.4 is 0. So we expect her to make 0.96 points every time she goes to shoot a 1-in-1, which is kind of interesting. She'll never score 0.96 points, but on average, she should basically make a 1, even though that's the least likely thing to happen. Just these kind of even out pretty close to 1. So again, pretty interesting, the expected value versus what you can actually do. So it says repeat Part A for at least 3 other possible free throw percentages, making a note of the most likely outcome for each one. I'm not going to do that, so I guess I'm lazy. Here's what it looks like. I'm going to pause the video and set up the next problem. Has presented her with an opportunity to raise her grade. She can roll a special dice and possibly gain points. If Janine rolls a positive number, she will gain the number of points indicated on the dice. However, if she rolls a negative number, then she will lose that many points. It's unlikely your teacher would ever put you in this position. Anyways, Janine doesn't know what to do. The dice formed when the net outright is folded offers 4 sides that will increase her number of points and only 2 sides that decrease her grade. She needs your help to determine if this dice is fair. So first of all, we expect to gain points more often than we expect to lose points, but that still doesn't mean it's fair, and that still doesn't mean that the expected value is positive. It's just that a good thing happens more than a bad thing, but the bad thing might be worse than the good thing, and offset it, right? If I told you, hey, you know, let's flip a coin. If you win, I'll give you $1. If you lose, you give me, well, that's a bad example. Let's roll a dice. If you get a 1 through 5, I'll give you $1. If you get a 6, you give me $1,000. Well, obviously, the odds of you winning is better than the odds of you losing, but the odds of you losing, but when you do lose, it's way worse than when you do win. So that's kind of what we're looking at here. What are we seeing? So what are the qualities of a fair game? It has to be even, right? You should be able to have an expected value of 0 so that it's fair. How can you tell if a game is fair? Again, we're going to look at expected value and see if it equals 0. So what is the expected value of one roll of dice? Well, I might get a 2. I might get a 2, or a 1. Or I might lose 4. So these are the 6 things that can happen. So I'm going to add these points up and divide by 6. So 2, 4, 6, 7. Minus 4 is 3. Minus 4 is -1. So this is not a fair game because even though the -4s only happen twice, they offset the games. So is this dice fair? No. Expected value equals -1/6. It says change only one side of the dice in order to make the expected value 0. Well, there's almost anything you can do because you're only off by 1. So if I change a 2 to a 3, just 1 2 to a 3, now my expected value is 0, and all of a sudden it's a fair dice. So, or I could make a -4 and -3. The long story short is I just need to add 1 to anything. If I add 1 to any of these, I'll get a fair dice. So again, that could go to a 3, that could go to a 3, that could add 1 to a -3, add 1 to a 3, add 1 to a 2, or add 1 to a -3. Any of those would make this a fair dice. What does it mean if a dice or spinner has an expected value of 0? It means it's a fair game. Because it doesn't matter if you win or lose more often, it just means that winning or losing is offset by that. So let me pause and set up the next question. Okay, it says examine the spinner at the right. If the central angle of region A is 7 degrees, calculate the expected value of one spin using 2 different methods. So be ready to share. So here's how I would do this. I mean, you might do it a different way, but the first thing I would say is I know there's 360 degrees in a circle. So I would say, all right, I'm going to get 7 out of 360 times, and I'm going to get a 2, 353 out of 360 times. And what do I get here? So I'm going to go ahead and I will grab a calculator and I will multiply 100 times 7, which is obviously 700, and divide that by 360, and I get 1.944. Repeating, and I will add that to 2 times 353 divided by 360. So 1.961 repeating. So I expect, even though the 100 only happens 7 times out of 360, it's actually worth more than the 2, even though it almost always happens there, which is kind of interesting. Now I'll just add these together. So I'll add that plus 1.9444444, and I get a 3.91, I guess. It's not exactly. So I get about 3.91. That's my expected value. Another way I could do it is I could say, look, if I spun this thing 360 points, right, I would expect 7 times 100, right? This happens 7 times out of 360, so 7 times I would get 100 points. So 7 times I would get 100 points. So that's worth 700 points. 353 times I would get 2 points. So that's worth 706 points. Yeah, I misspoke when I said that this was worth more than this. Clearly 1.96 is worth more than 1.94. So I did misspeak. Even though this happens only 7 times, it's worth nearly as much, but it's not worth more. I was saying the 4 is more than the 1, but I missed that 6, so I apologize. I hope that makes sense. But the bottom line is I would make 1,406 points out of these 360. So if I divide 1,406 by that 360, I get an expected value of 3.90. Again, it's about 3.91. So every time I spin this, I expect to get about 3.91 points. And again, I apologize for misspeaking on this. 1.94 is less than 1.96. So this 2 value is higher than this 100 value just because it happens so many more times as far as the expected value goes. All right, let me pause and set up the last question. Okay, and for the last one, it's kind of interesting. They want us to reverse the process and figure out what x is so that we get an expected value of 3. So there's a couple different ways of thinking about this. One way I could do is say, all right, if I get x amount of points a quarter of the time, and I get 2 points 3/4 of the time, how can I make this equal to 3? So what I'll do is I'll get x over 4, right? Multiply the tops, multiply the bottoms, plus 6 over 4 is equal to 3. Well, think about this. Wouldn't it be easier if this thing was over 4 itself? So I will multiply it by 1 in the form of 4 over 4. So I have a common denominator. So I get 12 over 4. Well, look at that then. I guess x needs to equal 6 because 6 plus 6 equals 12. So if this had a value of 6, I would get that thing working out. Another way you could look at this is, let me go ahead and just sort of clear this out. Another way you could look at this one is you could say, what if I instead said, all right, well, I know that I get a 2 one time, right? I'm just going to break this into quarters. So 3 times I get a 2, the 4th times I get an x, and whatever that is, I wanted to be able to divide it by 4 and have it equal to 3, right? So think about that. Then this whole thing needs to equal 12 because 12 divided by 4 equals 3. So 2, 4, 6 plus 6 equals 12. So either way would be fine. I literally don't care which way you do it. As a matter of fact, though, I will say when you get to fractions, I think it's easier to do the one setup. Now, don't forget that 60 over 360 is the same as 1/6. So 1/6 of the time we get a negative 3. 1/6 of the time we get a 1. And that must mean, right, 1, 2, so 4/6 of the time we get an x, and we're going to make it equal to 3. I'm probably just going to solve these using this. I think it's easier this way. Some of you might not. Feel free to use the other way. I don't care. As long as you get the right answer, that's all that matters. So I get 4x, I'm sorry, this should be plus 4x over 6 equals, and again, I can call this 3, or I can just call this 18 over 6 as a nice little shortcut, right? Isn't 3 the same? 18 divided by 6 equals 3, but now I have this common denominator. So I can just worry about the numerators. Negative 3 plus 1 plus 4x is equal to 18. So I get negative 2 plus 4x equals 18. I'll add 2 to each side. I will get 4x equals 20. Divide by 4, so x equals 5. So if this x equals 5, I would also end up getting a 3. And again, think about that. I can check my answer. If I have 4 5s, don't forget this is 4 6, right? So I have 1, 2, 3, 4 5s with a negative 3 and a 1. And a 1. 5, 10, 15, 20, minus 3, 17, plus 1 is 18. And then I divide that by 6 opportunities, I get my expected value of 3. So I'll solve it using this way and then check it using this way. That's not a bad way to do it. And then finally, and again, it's really important I know my proportions. So obviously this is going to be a quarter. 90 over 360, this is going to be a quarter. Well, 40 over 360 is going to equal 1/9. So this one is 1/9. And then this one must be 140, right? This is straight line's 180 degrees. I've just taken 40 of it. So all that's left is 140. So 140 over 360 is going to equal 14 over 36, which is 7 over 18. So this one is going to be 7/18. So they're really giving us an ugly one here for sure. But that's fine. We'll be fine. So what might not be bad is getting a common denominator. So I think 36 is going to be a good common denominator to use because they all go into 36. So this would be like 14 over 36. So 14 over 36 times, I get a 9. Let me redo that. By the way, this is like a high level question, so don't feel bad if you're struggling with this one. Maybe you can watch it twice or let me know if you have some questions. I'm going to get an 18. Again, I have to multiply by 4 over 4, so I'll get 4 over 36. plus this is going to be I have to multiply by 9, so I'll get a negative 3, 9 over 36. That's a negative 3. Plus, I'm going to get x, and that's also going to be 9 over 36, so I'll get x times 9 over 36. So I'm running out of room here. Long story short, I'm going to grab a calculator. I'm going to multiply 14 times 9. I'm going to get 126 over 36 plus 18 times 4 is 72 over 36 plus, actually that should be minus, right? I'm actually subtracting. That's minus 27 over 36 plus, this is going to be, I can barely even tell what this says. I think it's 9x over 36. And that's got to equal whatever 3 is, and it's just going to be 3 over 1, which I'll multiply by 36. So that's going to be 108 over 36, because 108 divided by 36 equals 3. So a lot going on with this problem, but now I don't need the denominators. I have my common denominators. I'll just worry about the numerators. So I'm going to have 126 plus 72 minus 27 plus 9x is equal to 108. I will solve this thing. 126 plus 72 minus 27 equals 171 plus 9x equals 108. I'll subtract 171. I will get 9x is equal to whatever 108 minus 171 is. And I get negative 63. So x, and then I have to divide that by 9. So obviously negative 63 by 9 is negative 7. So a very difficult problem. As a matter of fact, I'm going to jump over and make sure I got that one even right. So let's look at the answers here and see if I got negative 7. This kind of freezes when I do this, so bear with me, sorry. There we go, went too far. X does equal negative 7, so yay, we got that right. I may as well check the other two, 5 and 6. That works as well. Don't feel bad on C, that was kind of a horrific problem, but you can see just using fractions and setting it up, we can still solve it. I probably should have given myself some more room. I apologize.